Good morning, everybody. I was asked by Dr. Kotra to just do the catalase and the oxidase experiments because you did not get to finish your meat lab, okay? So let me just guide you through it here. So here I have a set of unknowns. So what I've done, just to clear up what A, B, and C are, those are these cultures here that I isolated using your meat samples. So I took single colonies and I grew them overnight, and as you can see, everything grew bacteria in it, right? And because it's one colony, it's one population of bacteria. And here I have my positive controls for the catalase test, which is E. coli, and then P. pseudomonas, P. fluorescens for the oxidase experiment. So catalase positive, and this is oxidase positive. And here are the chemicals that we're using for this experiment, which is hydrogen peroxide for the catalase experiments, and then 1% TMPD and 1% naphthol for the Pseudomonas oxidase experiments, okay? So what I've done, so we can save some time, is I have already pipetted the chemicals. Those tubes contain hydrogen peroxide, 0.5 ml of hydrogen peroxide. And then these tubes here contain TMPD, which is this brownish reagent, and 1% naphthol or alpha naphthol, which is actually clear. So what we're going to do is we're going to add bacteria to these tubes, and then we're going to vortex them, and then we're going to be able to assess whether they're catalase positive or oxidase positive, okay? So I'm going to place my phone in front of me. So we're going to start with a catalase experiment. So we're going to use the positive control, which is E. coli. So here I have the tube of E. coli so you can actually see. Okay, I'm going to take 0.5 ml of that, and then I'm going to place it into the tube here in the corner. So then we're going to quickly vortex it because it says vortex for a few seconds. My apologies for the sound of this vortexing right here. And then let's see what happened. So as you guys see, there is a lot of vigorous evolution of bubbles, which is actually molecular oxygen. And catalase, as you guys remember, is the antioxidant enzyme that detoxifies reactive oxygen species such as hydrogen peroxide. So when you break down hydrogen peroxide, you generate water and molecular oxygen. These are the bubbles that you actually see right here. It's quite a positive reaction. So now let's try to add the cultures from the unknowns to the rest of the tubes here, A, B, C, and D. A, B, and C, sorry, and then see what happens. So we're going to add 0.5 ml of A to the tube here. Let's vortex it quickly so we can see what we got. Vortex this for a few seconds, and as you can guys see again here, compared to the E. coli one, they're both quite bubbly. So there's a lot of oxygen bubbles generated. So I would think personally that A would be catalase positive like E. coli, okay? Now we're gonna repeat the same procedure for unknown B. So B is here. I'm gonna take another 0.5 ml, 500 microliters of this, add it to the tube, to B, vortex briefly, and see what happens. It's very obvious as well that this second colony that I isolated, it's also catalase positive, and you can actually see how it compares to the positive control, okay? Now let's do known C, and in between, guys, I'm changing tips so we have no cross-contamination. You always use a new tip between different cultures, and that's my unknown C. And then I'm gonna add some of that to my last tube over here, and then see what happens. I'm gonna vortex it, it's in here, and then let's see what's going on. This one, guys, I don't really see much bubbles forming at all compared to, let's say, the positive control. You can see the difference, right? There's a lot of oxygen in the first tube, in the positive, and then in the unknown C, there's absolutely no catalase activity, meaning that these particular bacterium that we don't know what it is. It doesn't really express any of the enzyme catalase, okay? So again, just to go through it again, we have E. coli here and unknown A, so both have bubbles. Then we have E. coli and unknown B, and they both have bubbles. Then we have E. coli and culture C, and as you can see, culture C has no catalase activity at all compared to E. coli. So now, guys, we're gonna move on and do the experiment for the oxidase, right? So now, if we get a positive result, we're supposed to have the reagent turning dark blue, okay? So as you can see, it's a very faint brown color. And if we have a positive test, we're supposed to get a blue color. So let's use the positive control, which is Pseudomonas, and see what happens. So I'm gonna pipette 1.125 mils of this into my tube and then see what happens. Okay, so here we have the culture. Then we will vortex this. And then see what happens. So we have to vortex about 30 seconds. And look what's going on, guys. It turned very, very deep blue, okay? So this is Pseudomonas, right? So it's very dark. So that means that blue is positive for oxidase. So it expresses cytochrome C oxidase. And if you guys remember, cytochrome C oxidase is the last enzyme in the electron transport chain. So it just transfers electrons and protons to the final acceptor of electrons, which is the oxygen, to produce water. And it also transports another 4 protons that are used to create the electromotive gradient in the mitochondrial membrane by ATP, which is used by ATP synthase to synthesize ATP, okay? So it's a very crucial enzyme. So you can see that fluorescence is very dark blue. Now let's assess what happens with the rest of the unknowns. So we have unknown A, so let's drop 1.125 mils in and see what color we get. Okay, so we have to vortex for 25-30 seconds. So bear with me, it's quite noisy. So as you can see, guys, we vortex, but the unknown A did not really change color. So it stays kind of, you know, brownish. So this is a negative for oxidase, okay, compared to the positive control, which is B fluorescence. Now let's move on to the second sample and see what this is. So the other unknown that we have, we're gonna add 1.125 mils into the tube, vortex for 30 seconds, and let's see what happens. This one, guys, as you can see, turned bright blue like the positive control, okay? And then you can see the difference between the first unknown, the second unknown, and the control. So we know one is negative, B is positive. And now let's move on to the last sample, the last unknown that we have, and see what that gives us. So this is unknown C. I'm gonna pipe at 1.125 mils. We're gonna vortex vigorously for another 25-30 seconds and observe the results. As you can see, most of them are almost instantaneous. The results are instantaneous. So as you can see, this one here, guys, also did not turn blue, as opposed to the positive control P fluorescence. So again, just to go through all the samples again, A is negative, B is positive, and C is also negative. So this is what you would see if you got to finish the experiment. And those are again tests that we use to identify different types of bacteria. I hope everybody has a great day, and I'll see you around. Bye-bye.